Kids, these are our pre-10a notes on how to add and subtract fractions with different denominators. So just to kind of think to the side, if I were to ask you to add 5/6 and 3/10, you know that you would need a common denominator. Right? And one way we can always get a common denominator is just to multiply your two denominators together. 6 times 10 equals 60. And then multiply each numerator by the other fraction's denominator. So we would multiply this fraction by 10 over 10, this one by 3 over 3, which gives us 50. By 6 over 6, which gives us 50 plus 18, which is 68 over 60, which if we reduce by 4, right, dividing each by 4, gives us 17 over 15. Well, we did that with a common denominator, but it wasn't the lowest common denominator. If we come back and redo this problem, right, the smallest number that both 6 and 10 divide into is actually 30. So I would multiply this fraction by 5 over 5 and this by 3 over 3, which gives us 25 plus 9, or 34 over 30, right, which reduces to 17 over 15. So what we're going to look at with algebraic denominators with x in, is how to find that lowest common denominator. And just with numbers, the idea is this. If I take my denominators here, which were 6 and 10, and I prime factor them, 6 is 2 times 3, 10 is 2 times 5, my LCD is going to use a 2 because both numbers have a factor of 2, and then I'm going to have to pick up the 3, so the 6 will divide into it, and then the 5. Right? 2 times 3, 6 times 5 is 30, and my LCD is 30. So when I multiply this fraction by 5 over 5, right, the 2 times 3 is my 6, the factor I'm missing is 5. When I multiply, right, this fraction by 3 over 3, the 10 is taken care of with the 2 times 5. I'm going to multiply by the missing factor of 3. So that's the idea we're going to use with algebraic fractions. So I'm going to erase this so I've got my space, right, but I wanted you to see that with numbers before we start throwing in algebraic expressions. So here are the steps we're going to follow. The first thing we're going to do is factor each denominator to help us find the LCD. So if I do that here, right, then I have my denominators, right, which this is going to factor as x plus 3 times x minus 1. And then this denominator, which factors as x plus 3 times x minus 1. Now I'm going to determine my LCD, and that LCD should contain all the factors of each denominator. So I need enough factors that would contain each denominator. And the way I'm going to do that is where I have factors that are in common, I'm going to take the highest power I have in any one denominator. So since these are both to the first, I'm going to take an x plus 3. Okay. Now I'm going to take any other factors that are unique, that only show up once. So I've got this x minus 1 that shows up in this denominator, and then I have this x minus, this was x minus 3. X minus 3. And that's my LCD. So now I'm going to come back to my fraction, and I'm going to take my numerators, 3x minus 1, over my factor denominators, x plus 3 times x minus 1, minus, and I'm going to leave a gap because I'm going to multiply, and my second fraction has a numerator of x plus 4, and a denominator of x plus 3 times x minus 3. And I'm going to come in and I'm going to multiply each fraction by whatever factor that is missing from the LCD. So x plus 3 and x minus 1, right, has those two factors. What it's missing is this x minus 3. So I'm going to multiply x minus 3 top and bottom. Now I'm going to look at my second fraction, and my second fraction has this x plus 3, right, and it has the x minus 3. What it's missing is this x minus 1. So I'm going to multiply top and bottom by x minus 1. So now both fractions have a common denominator. So I'm going to come in here and I'm going to write down that common denominator, x minus 3 times x plus 3 times x minus 1. And I'm going to multiply each number, each set of numerators together, and I'm going to put them in parentheses so I don't lose the grouping of it. So when I come in here, I'm going to multiply this x minus 3 times 3x minus 1. If I FOIL those together, I get 3x squared minus x minus 9x, so minus 10x, and then multiplying my last, I get plus 3. Now I have a subtraction, and multiplying my next numerators together, putting those in parentheses, I get x squared, right, plus 4x minus x plus 3x minus 4. All right, now we're going to simplify that numerator. So I'm going to distribute my subtraction, so that changes this to plus, this goes to minus, this goes to minus, this goes to plus. I'm going to combine my like terms, and I get 3x squared minus x squared is 2x squared. I have my negative 10x minus 3x is negative 13x, and then I have a plus 3 and a plus 4 is plus 7. And all of that is over my common denominator of x minus 3 times x plus 3 times x minus 1. Okay. So my next step would be to factor the numerator, and the purpose of that is to see if there are any common factors that we can divide out to reduce this. So if I attempt to do that here, what I find is this 2x squared minus 13x plus 7 doesn't actually factor. So we could play with that, but it doesn't factor. And there are no common factors between the numerator and denominator, so this is not applicable. I can't do that, and what I'm left with is my fraction in the simplest possible form. And you'll notice that I have left the denominator factored. Remember, we're building tools for our toolbox that we can use to answer questions, to solve problems, to make predictions. And when we have a fraction, usually it's easier if we have it in factored form. So although we could multiply those together, we're just going to leave them alone. Isn't that good news? Right? So we're done. Let's do another example. So here I have three fractions together, and I am both adding and subtracting. And we're going to start by factoring each denominator. So I've got x squared minus 4, which is x plus 2 times x minus 2. I have this denominator, 2 minus x, and then I have this denominator, which is x plus 2. Now before we go farther, I want to remind you of something, and that is, so we'll take note here, that is that a minus b is the same thing as the opposite of b minus a. So subtraction is not commutative, but if it's useful for us to switch the order of numbers we're subtracting, we can do that as long as we factor out a negative. So one thing I notice is that here I have x minus 2, here I have 2 minus x. If I switch the order of this subtraction, then I'm going to have a common factor, and that's going to make my common denominator smaller. Smaller is a good thing. So I'm going to take this subtraction and I'm going to replace it with the opposite of x minus 2. So now when we build our LCD is going to be made up of any factors that are common. So if I look in here, right, x plus 2 is a common factor between two of my denominators. The largest power I have of x plus 2 is x plus 2 to the 1. So I'm going to take an x plus 2. Right? And then I have a common factor now of x minus 2. And again, the largest power I have is to the first, so I'm going to take an x minus 2. Right? And I also have the negative. And so we could take the negative and place it up here, changing the positive to negative, or we can take it in the LCD. So I think I'm going to leave it. So I'm going to take this negative and I'm going to apply it to the entire fraction to change that to subtraction. Okay, so now we're going to get our LCD by multiplying each fraction. So I'm going to come in here and I've got my x plus 2 times x minus 2 with a 2x in the numerator. And then I had my minus because I changed the sign. I'm going to leave a gap, and I have 5 over, and we change that denominator to x minus 2. Then I have minus. I'm going to leave a gap again, and I have 1 over x plus 2. So when I look at this first fraction, right, my LCD was x plus 2 times x minus 2, and this fraction already has both of those denominators. I don't need to change it. My second fraction has the x minus 2, but not the x plus 2. So I'm going to multiply top and bottom by x plus 2. My third fraction has the x plus 2, but not the x minus 2. So I'm going to multiply top and bottom by x minus 2. And now I'm going to multiply my numerators together, and I'm going to put them in parentheses. I promise this will save you mistakes. So in my first, right, so I've got my big fraction now with my common denominator, x plus 2 times x minus 2. My first numerator in parentheses is 2x. Then I have minus. My second numerator, which comes from multiplying x plus 2 times 5 together, is 5x plus 10. Then I have minus. And my third number, which comes from multiplying x minus 2 times 1, is x minus 2. Okay, now we're going to simplify that numerator. To do that, I'm going to distribute my subtractions. So this changes to plus, and both of these signs change. This changes to plus, and the x changes to minus and this to plus. So when I combine my like terms, I've got my 2x, my negative 5x, and my negative x, which is negative 4x. And then I have my negative 10 and my positive 2, which is minus 8. And that is all over x plus 2 times x minus 2. Now we're going to factor our numerator. We have a GCF of negative 4, so if I pull out negative 4, that leaves me x plus 2 over my x plus 2 times x minus 2. The reason we factor the numerator is to identify any common factors that we can divide out, and here we can divide out x plus 2, which leaves us negative 4 over x minus 2, and that is my simplified fraction. Okay, so we got that rolling. I'm going to go through just a couple more examples here for you. On your response, on your Google form, you're going to do problem 1 and problem 4, but 2 and 3 just involve something a little bit different, so let's just look through those. And I'm going to do these horizontally. But the first thing I'm going to do when I do number 2 is I noticed that my denominators are reverse subtractions. So like I did earlier, I'm going to take this s minus r and I'm going to reverse the order of that subtraction, which I can do if I can bring out a negative, and I'm going to bring out the negative in front of the fraction, which changes this to subtraction. So that gives me now, right, r minus s, same factor, so I already have a common denominator, and that leaves me with my numerators r squared minus s squared. I'm going to factor the top, that is r minus s, times r plus s over r minus s. We have a common factor we divide out, and we are left with r plus s, and that's our final answer. So recognizing that we can switch this subtraction made this much easier than if we were to look at those as different denominators and create a larger denominator for the common one. Let's look at number 3. So for number 3, I've got my y minus 2, and again, grouping can be really helpful here. And then I have 4 plus 8, and I'm going to factor out the 4, which gives me y plus 2. Then I have minus y plus 6 over here. I'm going to factor out the 3, which leaves me 2y minus 3. So now when I add these together, I'm going to need a common denominator. So 4 is just 2 by 2 times 2. So between the coefficients here, I don't have any common factors. So my LCD is going to multiply those two together, and I get 12. And then y plus 2, right, is unique, so I'm going to take a y plus 2. And then 2y plus 3 is unique, so I'm going to take a minus 3. So when I go to this first fraction, in order to get a 12, I'm going to have to multiply 4 by 3. So I'm going to have to multiply this by 3, top and bottom. And then I am missing the 2y minus 3, so I'm going to have to multiply by 2y minus 3, top and bottom. In the second fraction, I have a 3, I need a 12, so I'm going to have to multiply by 4 over 4. And I have a 2y minus 3, but not the y plus 2, so I'm going to have to multiply by y plus 2. So if I take this first fraction and I simplify these numerators, right, I've got y minus 2 times 2y minus 3, which is going to give me 2y squared, right, minus 3 minus 3y minus 4y is minus 7y, and then plus 6, which still has to be multiplied by the 3. I haven't multiplied by that yet. So that gives me 6y squared minus 21y plus 18 from my first numerator. Then I have my minus, right, this minus here, and now I'm going to take these binomials, multiply those together, and that gives me y squared plus 2y plus 6y plus 8y plus 12. And that still needs to be multiplied by the 4. So that gives me 4y squared plus 32y plus 16. Distributing my subtraction, right? So coming in here, changing this to plus, and then each of these signs change, and combining like terms, I get 6y squared minus 4y squared is 2y squared. Negative 21y minus 32y is minus 53y, and then plus 18 minus 16 is plus 2. and that is over 12 times y plus 2 times 2y minus 3. This numerator won't factor, so that is my final answer. Okay, that takes care of it for us. I know that you've done this before, and looking forward to see you do great things